Good afternoon. Today we are continuing with our Unit 11, right? Unit 11, working with yesterday we worked with points and lines and planes. Today we are starting to talk about those angles, how we measure the angles, and we're going to be going into this unit doing more with angles. Right now, we are learning about our protractor, CO65. I can measure, draw, and classify angles using a protractor. So, first things first, this is a protractor. A half circle, half moon is the protractor. The one with the pencil that you can swing in and out, that is a compass. A lot of times protractors and compasses come in the same package. We are just working with protractors in this unit. So this unit, we're using the protractor piece. So doesn't matter the size of your protractor. Sometimes you'll see small protractors. Sometimes they'll be big protractors. They all have the same angle measurements on it. So all protractors, just like all rulers measure the same, all protractors measure the same. Okay, so if yours looks slightly different than the one that's in the classroom, it's okay. It's just like rulers look different. They all have the exact same measurement on it. So we're going to notice a few things about our protractors. So we have a 0 right here on the outside. And we count up 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, 130, 140, 150, 160, 170, 180. So, notice that this is a straight line. What are those numbers telling us? On a ruler, the numbers tell us inches or centimeters, meters, depending on what type of ruler it is. What are these numbers telling us, Gus? Degrees. So these numbers are telling us degrees. So if we notice going from 0, if we go all the way around to 100, what is that? That is 180 degrees. There's a different name we give for it. I'm jumping ahead. It's a straight line. A straight angle is 180 degrees. That straight line goes from one end of the protractor straight across to the other, and that is a straight line. You are right, Emlyn. We do have different angle measurements that have different names, and we are going to learn how to classify those by name. So, first thing I want to point out, though, is we have numbers on the outside, and then we have numbers on the inside. And they go the opposite direction. On the inside, they start at the right with the 0, and they go around all the way to the left 180. On the outside, they start at the left, and they go around to the right. Why do you think that is? Why do we have two different sets of numbers going opposite directions? Mario? Our angles can open up to the left, our angles can open up to the right. So we'll notice you can measure angles that open left. If we had our angle was like this, and it opened up like that, would we use the outside numbers or the inside numbers? I heard somebody say outside. Why would I use the outside numbers? We always want to look at our bottom part of our angle. Which side is that pointing to? You want it pointing to the 0, because we always want to start our counting at 0. So it's pointing to the left. So that means the 0 is on the left. We're going to count on the outside to see how big our angle is. And we're going to look at that outside measurement. So look at the bottom of your angle. You want it to point to the 0. So if our angle was this one that opens to the right, we would want our zeros on the inside, so we would want to count up on the inside. So you're looking at where the bottom line is pointing to the zero. The zeros on the outside, use your outside numbers. The zeros on the inside, use the inside numbers. Because if it is a really big angle, what do we call that? Obtuse. Obtuse angles are bigger than 90 degrees, right? So we know 90 degrees goes straight up and down. It's that right angle. That's 90 degrees. An obtuse angle is going to be bigger than 90. So this angle right here, ooh, that red angle is a big angle. It's going to be bigger than 90 degrees. And if we said it was 50 degrees, 50 degrees is smaller than 90. That's what do we call smaller than 90? Acute. It's so cute and little. Acute angles are smaller than 90. So always double check when you're using a protractor. If your angle is obviously bigger than 90 degrees, it's an obtuse angle, you should not give an answer that is an acute angle measurement. That's how you can double check using a protractor. Did I use the right set of numbers, the outside or the inside? If you're getting a number that is an acute degree, smaller than 90, and it's an obtuse angle, that's your clue that, ooh, I used the wrong set of numbers. I need to go again, checking on the other side. So just logically look at it. Does this angle logically look like it would be acute or obtuse? Yes. So that's a good question. Emmeline asked if all protractors have a zero on it. So my classroom set, you'll notice it doesn't have a zero listed always. So when I look at that, I just know that if it's going 10, 20, 30, 40, there's a zero underneath it. So just logically know that the zero is below the 10. So you know that, look at the direction your numbers are going up, you know the zero's under. Did that make sense, Emmeline? So on here, if we look at this protractor, if it's like the one that you have in front of you, that zero isn't written. So logically, where would the zero be? Is it going to be over here by the 180? Or is it going to be under the 10? Where would you find zero? Under the 10. So if it's not written, you just know that's where it is. Because logically, you wouldn't put a zero at the 180, right? So sometimes they don't have them written onto the protractor. We just know that that's where the zero is. Okay. That was a good question. Any other questions about a protractor? Okay, when we use our protractor, my nice big yellow protractor has a little spot for me to put my pencil that I'm going to put the angle of the vertex of my angle I would put right here. So it doesn't, sometimes it gets goofy with the smartboard, but I would align this up so my pencil would go straight at that vertex of the angle, and I want to have this straight line be right here. And then I would follow this angle up, all the way up to here. Oops, it's getting goofy because I have it up. But I would follow this angle up to here to see where my it is. And I see that the bottom of the angle is pointing to the outside numbers. So I would come all the way up here, and it was up there on my on my protractor, so I can see that it's 110 degrees. So I know that this angle, got all goofy because I was putting something on the smartboard, but this angle would be 110 degrees. On your protractors that have the little circle right here, that's where you want to line up your vertex. The vertex of your angle lines up in that little hole if you have a hole. Some of us don't have a hole, they might just have a dot. That's where what you put your vertex on. This is your vertex where the two lines meet. On my classroom set of protractors, you'll see there is a black line that comes out of that circle. That's what you want to line up on top of that bottom line of your angle. So line up that line on your protractor onto the line right here. Measure this acute angle and tell me what degree that is. I'm going to give people a chance. So measure that acute angle and tell me what degree you think it is. Raise your hand when you have an idea. I'm giving people a chance to use that protractor, so there should be nobody on a different part of this page because I've asked us to do something. Nobody should be on a different part of the page. We are all measuring this one angle right here. Raise your hand when you have an angle measurement. Do you have an angle measurement? Luca, do you have an angle measurement? So what did I say to do? I need to know when we have it measured. Raise your hand when you have a measurement, because I'm giving people a chance to practice with the protractor. So you're not doing what I asked. I asked you to measure. Oh, you are. I'm sorry. I thought it was this one. You was covered. You're good. Thank you. Finish measuring that one. Frida, you got a question about the protractor? Okay. All right. What measurement did you get, Chris? Chris at 70 degrees. What measurement did you get, James? 65. I don't know why. Okay, you got. Oh my goodness. My smartboard is not happy with me. All right. So we have a 70 degrees. We have a 65 degrees. What else did we get? Evan. What else? A different number. If you got a different number. See, good. 60. What did you get, Emmett? 62. Any other numbers? Michael? 75. So we have quite a range here. Tatum, do you have a different number?
I was going to say 64.
64. I asked us to measure this one though. Okay. So we're just focusing on one angle right now. Why do you think we have such a range of numbers? Evelyn?
Because it goes like between 70 and 60.
Okay. Because it kind of goes between that 60 and 70. We do have those marks up here. These marks up here still count down here. Why else might we have different measurements? Gus?
Some people have different holes in places, like stages on top of the bar.
So it shouldn't matter where the hole is because the numbers will be slightly different position. So let me see yours real quick, James. Just like with a ruler, the rulers, yeah, see, on mine, my numbers come way down because that's where my hole is. On James, the numbers are up higher. So that's what I said. Just like with a ruler, the rulers can look different, but they measure the exact same way because the numbers are going to line up a little bit different. Evelyn? Somebody might not have drawn a completely straight line up to where they need to go. Or when they lined up their protractor, they didn't line it up precisely enough. If you line it up a little bit off, you're gonna get a very off degree. You have to line that line up. Remember I said, a lot of them have a straight line. You have to line it up straight. You have to make sure your vertex is right here. Evan,
I was gonna say, when like I put it down first on my paper, when I was looking up, like my blue had a blue to like block the blue angle.
is it hard to see with the darker color? So you can always use one of my clear ones if the blue is too hard to see out of. But if it's hard to see and you get the wrong number, what's better, the pretty one or the one that gets us the right answer? So, all right, let's look at this, because here's the deal, folks. I will not accept this big of a range. From 60 to 75, that is 15 degrees difference. 15 degrees is a lot. So let me show you how it works when we measure, because I understand it's hard to be exactly precise. I understand there's a little wiggle room, not 15 degrees wiggle room. Okay, so I line mine up. I'm gonna go right up to here, which is, I'm gonna follow that line all the way up to where the small lines are, between the 110 and 120, so I can be even more precise. And I see that my line is right in the middle of 60 and 75. Sorry, right in the middle of 60 and 70. So on my answer key, I'm gonna write 65 degrees because I lined it up precisely. I will accept a few degrees above and a few degrees below. A few being 2-3 degrees, not 10 degrees, not 5 degrees. So 65 was the answer I got. I would accept 62, I would accept 64. Okay. If we're too far away, we are not measuring precise enough. You need to work with your tools to be more precise. Okay. Just like with a ruler, you have to line up the end of what you're measuring with the end of the ruler and count it. You have to be precise with it. You have to be precise with the protractor. You cannot go fast, because that's when we make little mistakes, like not lining up that bottom line and the vertex. If we don't line it up completely correct, that's when we make those mistakes and we get the wrong answer. Does that make sense? So I accept a little wiggle room, not a lot of wiggle room. So if we're getting it wrong, when we correct it tomorrow, it means you went too fast and you need to get more precise with lining it up. As we're working on this, if you have questions want to check to make sure that you're lining it up correctly, definitely we're going to do that. Before we work, we're going to go through our definitions. So the vertex of an angle, so I should see nobody on that second page. Everybody's on the first page writing out our definitions. Everybody's on that first page writing out definitions. And I expect everybody to write the definition on your binder sheet. So, anybody know the definition of a vertex of the angle? Evelyn?
Where the lines meet up in the middle.
The point where the two sides of an angle meet. So I was using that term when I was talking about our protractor. That vertex where the two lines meet is where you put in the middle of that circle. Emily, what is an acute angle, Emily?
Any angle
an angle with a measure less than 90 degrees. So to draw an example of an acute angle, it's acute, it's little and cute. Remember our 90-degree angle, 90-degree angles look like this. So if it's acute, it's going to be smaller than that. So anything smaller than 90 degrees is acute. What is a right angle? I just talked about it, Priya.
An angle that is a degree of 90.
An angle with a measure equal to 90 degrees. So when we talk about acute angles, there are lots of different acute angles, right? We can draw acute angles from 1 degree all the way up to 89 degrees. Lots of acute angles. How many right angles are there? One and only one. That right angle is perpendicular side. You get that little box there, and it is exactly 90 degrees. A right angle will always be 90 degrees. Do they always tell us 90 degrees? No, sometimes they give us this little box. So if you know there's a little box there, you know it is 90 degrees. Evan, what's the obtuse angle, Evan?
An angle with a measure over more than 90.
An angle with a measure, I'm going to get even more precise on you, Evan, and say greater than 90 degrees. So we know this is our 90 degrees, our right angle. So our obtuse angle is going to be bigger. Okay, there's not just one obtuse angle. It could be 91 degrees, it could be 179 degrees. An obtuse angle is bigger than 90, greater than 90 degrees, less than 180 degrees. I notice he doesn't have this one on your page. Who was paying attention and remembered what I talked about at the very beginning of this lesson? If it is exactly 180 degrees, what is it? Luca. A little more precise. What was that? Straight line. So we call it a straight angle. So a straight angle I would think it's good to know a straight angle is exactly 180 degrees. So you've got your vertex and it goes straight across. So that straight angle is a straight line. It is exactly 180 degrees. Good to know. Any questions so far? James? Oh, we haven't gotten to the other page yet. Any questions on this page before I erase? We're good with acute and obtuse and right angles. We're good with how to use the protractor correctly. All right. Let me erase and we can turn to our second page. To measure an angle with a protractor, position the vertex of the angle at the center of your protractor. Okay, a lot of us have circles that you put that vertex in, making sure the bottom of the angle is flat along the bottom of the protractor. If you have that line coming out of your circle on your protractor, line it up directly above the line of your angle. If the angle doesn't reach the degree measures, you're going to visually extend or extend with your pencil So they've got this dotted line. You can actually draw your line going straight up to where the degrees are. What is the measure of the angle that is shown on this? Evelyn? Oh, okay, I will have to help you later. What is this angle measurement? Jonas? 45 degrees. We can't see the number written out as 45, but when we count it up, we can see this is 40, then 41, 42, 43, 44, 45. Why did I put my little circle next to my 45? Emmett? Because that's the measurement. It's not 45 inches. It's not 45 seconds. It's not 45 puppies. It is 45 degrees. So when we write degrees, what must we have? The degree symbol. Okay? When we write degrees, you must put the degree symbol. So, what is its classification? There are two questions here. What is the measurement of the angle and what is the classification? So if it's 45 degrees, what would I classify that as? Alexis? Acute. Why is it an acute angle, Alexis? It is less than 90 degrees. So you have to put the angle measurement and you have to be as precise as possible. I will not accept 5 degrees in either direction. Only a few degrees, right? Remember I said I wasn't going to take the 60 degrees when the measurement was 65. You have to be more precise. You have to count it closer. 5 degrees is too much of a difference. So on our angles, you need to measure the angle, write its degree with the degree symbol. You need to classify it, acute, 90 degree, acute, right, or obtuse angles. Then you're going to use your protractor and draw an angle that's 30 degrees and an angle that's 110 degrees. Be precise. We have time. So people that were rushing through trying to work on that back page when I was talking, yeah, we have time. This is not a rush. With math, we need to be patient and we need to be precise. We learned with our multi-step problems that if we weren't being patient with those problems, we were making simple math mistakes. With the protractor, be patient and be precise so you are measuring correctly. When you are finished with the math problem, you work on practice work, you work on Khan Academy, you work on Math Packet. I passed back all the practice work from yesterday. Some of us had to fix some things up. If you have questions on the practice work, come see me. This is what this time is for. Okay? I don't have the new video up for this Math Packet. Gus, where can you find my last year's video? Did you look it up yet? You're the one that usually looks it up, right? Oh, Chance.
I couldn't find it. I don't think they have one.
Did I not put up one yet? Oh,
There wasn't one in.
I don't think I did do a video.
2022 playlist.
Okay, so I don't have one. So I don't have it scanned onto my computer yet, so I can't do one today. Tomorrow, if we have work time, I will do the video in class. That's what I'm going to do with Math 6. Okay, so I'll do the video in class tomorrow, but be working on that packet. If you are watching this at home, we hope you are well. Please don't move. We hope you are well. We hope to see you soon. Have a wonderful day.